In section 10.3, we continue to look at quadratics, and now we're going to look at another way to solve equations. So if we have an equation like this, ax squared plus bx plus c equals 0, we've already looked at equations like this in different ways to solve them. Now we're going to look at solving them by graphing. And so the idea here is that we're going to graph them, and then we look for where the parabola will cross the x-axis. So that will be the 0 or zeros of the function. Very commonly you'll see two of them. So let's see how this works. Our first example, solve 3x squared minus 3x minus 6 equals 0 by graphing. And first of all, notice that our function is set equal to 0. That's good. Secondly, notice we could factor out a 3 here if we wanted to, and that would certainly help if we were setting up a table and graphing that way. But in this case, let's go ahead and use a graphing calculator, and so in that case I'm not really worried about those coefficients being larger than necessary. So here we have y equals 3x squared minus 3x minus 6. And we graph that, and we wait for it, and so we have this parabola. Now, when we go to draw the parabola, it's not important that we get our points exactly set. What we really want to focus on is those zeros. Where does the parabola cross the x-axis? And it looks like -1 and +2. Now, we don't know that for sure at this point, but we can certainly check that. So it looks like roughly something like this, very roughly. Okay. So roughly something like that, and it looks like -1 and 2. And we can ask, is that correct? So for x equals -1, substitute -1 into the quadratic and see what happens. We should get 0, hopefully. So we have 3 times -1 squared minus 3 times -1 minus 6. And this equals, -1 squared, of course, is +1 times 3 is 3. And then minus 3 times -1 will actually give us +3. And then minus 6, which is indeed 0. So that one checks. That is one of our zeros. Then for x equals 2, we have 3 times 2 squared minus 3 times 2 minus 6, which is equal to 2 squared is 4, times 3 is 12, minus 6, and then minus 6 again from the tail end here is equal to 0. So those are indeed our solutions. So x equals -1 or 2. Okay, number 2. Solve -2x squared minus 4x equals 2 by graphing. First of all, we want this set equal to 0, not equal to 2. And so I'm going to subtract 2 from each side. And notice that means we're going to end up with a -2 on the left side instead of a positive. So -2x squared minus 4x minus 2 equals 0. Again, we could simplify this by factoring out a 2, or even better yet, a -2. But if we're going to graph it, no worries. So we go back to y equals, and now we need -2x squared minus 4x minus 2. We graph that and look for our zeros. Okay, and now in this case it looks like there's really only the one zero at -1. So let's go ahead and make a rough sketch. Again, very rough sketch here, but basically something like this. And we want a little more curve there. So it appears that at -1 we have a solution. If we want, we could go ahead and substitute that into this equation and see if we get 2. So if we take x equals -1, we're going to have -2 times -1 squared minus 4 times -1. So we have -2 times a +1 because the -1 gets squared. So that's -2, and then minus 4 times -1 is minus a -4, or in other words, plus 4, and that equals 2. So x equals -1 is our solution. Okay, number 3, solve x squared plus 5 equals 2x by graphing. And again, we want this set equal to 0, so I'm going to subtract 2x from each side so that we end up with a negative 2x on the left side. So x squared minus 2x plus 5 equals 0. And then we graph that. So we go to y equals, and we have x squared, so I'm going to delete that, sorry, x squared minus 2x, and then plus 5. And we graph that, and notice that the parabola doesn't even touch the x-axis at any point. And what that means is there's no solution. So if we draw, again, a very rough sketch, so maybe something like this, we see there's no place that the parabola crosses the x-axis. There are no zeros. There's no value of x that will ever make this zero out, and so we have, in this case, no solution. Okay, and then number 4. A cannonball is launched into the air and follows the trajectory, h equals negative 16t squared plus 450t plus 10. And we've seen something like this before with a tennis ball, for example. And the question now is, determine how long it takes before the cannonball strikes the ground. So in other examples, we were looking for, say, the maximum height of the projectile. But in this case, we want to know the time, how long it takes before the cannonball strikes the ground. And the key here is that when the cannonball strikes the ground, h will be equal to 0. And so we take our equation here, negative 16t squared plus 450t plus 10, and we set that equal to 0. Now if we wanted, we could deal with some factoring and see if this will factor out nicely, or we could just grab our calculator and graph it. Let's do that. So we're going to go to y equals, and we have not minus. Need to go back there. Oops. There we go. Negative 16 and x squared plus 450x plus 10. And of course this isn't going to show up right now with our window set the way it is. We might see a little bit of it, but nope, so far it's not looking good. So let's go ahead and change our window. And we know that x is going to have to go out a little ways. Let's go ahead and take it out to 20. The big thing, though, is that our y value is going to have to be quite a bit greater than that. So let's make it, for example, 2,000 and see what happens. And we can change our y scale to, how about 500, just for fun. And let's see what happens now. See if we get an idea of what's going on. Okay, so we still need to go up higher to get that maximum height if we want. So we go back and check our window, and let's take the x max out a little more too. Let's go up to 30, and scale, let's go by 5s, and for y max, let's go ahead and double that to 4,000, and let's see what happens now. So we follow, and now we see it drop. Okay, so now what we want to do is find the 0. We know there's a 0 here at 0. Actually, sorry, that isn't 0, that's a 10. Because notice that the cannonball starts 10 feet above the ground. So at this scale, it looks like a 0, but it isn't quite. Now we could trace and move this along until it gets to the x-axis or pretty close to it, and we could try to estimate. We could zoom in and estimate and zoom in and keep zooming, or we could be slick and go to calculate. So second and then the trace button will give us calculate, and we'll look for a 0. And first of all, it says left bound, so we're looking for a point anywhere on this graph that's to the left of where our 0 will be, so that should work. And then for our right bound, we need to go actually below, and notice y is already negative, so we know that we're to the right of our 0. So I hit enter again, and guess. Okay, so we hit enter again and it will calculate that 0 for us. And we see that it's 28.147. I'm going to call it just 28.1. So rounded to the nearest tenth, we can say that t equals 28.1 seconds. So that's how long it's going to take for the cannonball to go through its arc and reach the ground again. Alright, so I hope you enjoy this section. Notice the assistance that we get with our calculators here, and hopefully you find that useful. Good luck.